Hello everyone, welcome to the second video of atomic structure, and today we will be discussing about the discovery of the three fundamental particles of atom, that is discovery of electron, discovery of proton and discovery of neutron, and we will also study about the properties of electrons. So let's begin. So before starting getting right into the topic, we will discuss a few things that why was this John Dalton's theory rejected? I mean, John Dalton said that atom is the most fundamental particle. Then why was this theory rejected? So the main reason of the rejection of this theory was the discovery of these fundamental particles, means more fundamental particles, that is discovery of electrons, then discovery of protons, and then discovery of neutrons. Okay, so now let's begin the topic. So discovery of electrons. So electrons were discovered by Sir J. Thomson in 1897 from cathode ray tube experiments. So what is cathode ray tube experiment? This is the entire setup of cathode ray tube experiment. Okay, so first of all we have this glass tube over here, which is known as a discharge tube. It is made up of glass, as I said, and then we have two metal plates. Okay, two metal plates which are connected to a battery, and this is a condition for this experiment to be successful, that the potential should be very high, up of about 10,000 volts. Okay, now the terminal which is connected, means the plate which is connected to the negative terminal, is termed as cathode, and the plate which is connected to the positive terminal is termed to be anode. Okay, then there is a few more things. One is that this anode is perforated. Why? I'll tell you later, don't worry. Next is that there is this fluorescent screen behind this anode, and this is a vacuum pump. Now what is the use of this vacuum pump? To suck in the air or gas present inside it, because the most important condition for this reaction, or sorry, this experiment to be successful, is that the gas or air in this must be at a very low pressure of about 10 to the power negative 3 millimeter of Hg, which means 0.001 millimeter of mercury. We live in, means the atmospheric pressure in which we live is 760 millimeters of mercury. So just imagine how low this is. Okay, so this is the experiment. So on doing all this setup, we find that some rays, some kind of rays, some kind of particles are moving from the negative plate to the positive plate, negative plate to the positive plate. Now these rays were known as cathode rays, but here I have written that these cathode rays are colorless. So if these cathode rays are colorless, then how do we get to know that these rays exist? So that is the reason why this perforations and this fluorescent screen has been made. The cathode rays travel through these perforations and hit this fluorescent screen, where they produce fluorescence, means they emit light, means just for example like radium, it sparkles in the night. Similarly, these are fluorescent screen, example is zinc sulfide. So when these cathode rays strike on them, they emit radiations, or they produce fluorescence. This is what we say about this. So this was the indication that there is something which is traveling from the negative terminal to the positive terminal, and these were known as cathode rays. So now let's discuss about the properties of these cathode rays. So I have written these properties in a particular order, but I will not go in this order, to be very frank. You will be asking me why. Well, I'll tell you later, means I'll just explain. You'll understand why I'm saying this. Okay, so first and foremost thing is that they produce fluorescence. They produce fluorescence. I told you this, that they produce fluorescence. Okay, when you have to learn this, you can learn this in this order, but for the sake of explanation, I'm just not following it. Okay, they produce fluorescence. The next thing is that they are negatively charged particles which are colorless. Yeah, since they are colorless, I already explained you. Now they are negatively charged particles. They are traveling from the negative side to the positive side, so definitely they are negatively charged particles. Now, there is one more way to explain how these particles are negatively charged. So that is, they are deflected in electric field and a negative, that is towards the positive plate, and in the magnetic field. So if they are charged particles, they will be deflected in electric and magnetic field. So they're deflected, but in the electric field they were deflected towards the positive plate, and in magnetic field they were deflected in the way a negatively charged particle should be developed, means it should be deflected. This thing means in which way it will be deflected, this will be given by Fleming's left hand rule. But now for present, let's understand electric field. So let's suppose you have a positive plate over here this side, okay, and you have a negative plate this side. So when these cathode rays will be traveling towards this, they will deflect towards this side because you have a positive, you have kept a positive plate over here. So this proves that these cathode rays are negatively charged. There is one more, means next point which we have is that they travel in a straight line and they are produced from cathode. So let's understand this. They are traveling in the straight line. Now if we keep an obstacle in their path, it is seen that in that path, it means in that part, the fluorescence is not produced. Means let's suppose here you have an obstacle like this. So behind this, the fluorescence will not be produced, which means that these cathode rays are being blocked. And when they will be blocked, they will be blocked only if they travel in the straight line, like it happens in case of light. And so this is how we prove that they travel in the straight line. So next, another thing is that they are produced from the cathode. Yes, they are produced from the cathode. Now to understand this, let's just imagine is that in today's days we definitely know that they are electrons only. Yeah, we definitely know that they are basically electrons. So what will you expect? From where are these electrons coming? The gas is at a very low pressure. So from the atoms or molecules of the gas, electron is not coming. So from where will the electrons come? Electrons will come from this electrode. This is a metal plate, so it will have free electrons. So when we apply a high potential, the electrons are attracted towards the positive plate, so they start moving in this direction. Okay. Next point is that they possess kinetic energy. How do we know that? Then in their path, small pedal wheels were placed, and it was seen that the pedals start moving and the wheel starts rotating. So we get that they have kinetic energy. And now one technical thing is that since they produce, means they contain kinetic energy, this proves that they are made up of small particles. What? They are made up of small particles, because particles are small. Why? Because they are not able, means we cannot see them, that is why they are colorless in nature. So they are small and they are made up of particles. Why? Because only particles can have kinetic energy. Kinetic energy is equals to half mv square. So here is the term of mass, and mass is a property of particles. So that means that these cathode rays definitely consist of particles. I hope you understood this. Next, the last and the most important point is here is that on changing the gas, means some gas is there, even if the pressure is very low, some gas is there because it is not exactly zero. So some gas is there. Or the electrode material, let's suppose this was first made up of iron, then we changed it into something else. Let's suppose we made it copper, and then we changed into silver, and then we changed into platinum, and then we changed into something else. Let's suppose we changed into zinc, we changed into manganese, and this and that and this and that. We found that the property of the cathode rays, these all properties did not change. And one more thing which did not change was the charge to mass ratio of the particles of the cathode rays, which was 1.75 into 10 to the power 11 coulomb per kilogram, and this was discovered by J.J. Thomson. This is the main reason why this entire discovery of electrons is credited to the name of J.J. Thomson. Okay, so it was found that the properties and all these things do not change. Therefore, it was proved that the particles of these cathode rays are the fundamental, what? They are the fundamental particles of matter. And these fundamental particles of matter were later renamed as electrons by another scientist named G.J. Stoney. So they were named as electrons. And then we study about the properties of electrons. So first is that they have negative charge on them, or we can say they are negatively charged. Okay, I guess you understand after all this explanation. Then it was means the charge on one electron was calculated, and it was found out to be negative 1.6 into 10 to the power minus 19 coulombs. And this was discovered by a scientist named as Millikan. Not that important to know how he discovered it. It is mainly the experiment is known as Millikan's oil drop experiment, and there he used electric and gravitational fields, means electric and magnetic fields, and along with the gravitational fields some kind of interactions were done, and due to that the charge on one electron was found out in this as negative 1.6 into 10 to the power minus 19 coulombs. Okay, and then mass of one electron was found out to be 9.1 into 10 to the power negative 31 kilograms, or you can also read it as 9.1 into 10 to the power negative 28 grams, whichever way you like it. But I guess the kilogram is the SI unit, so therefore it is more preferable. Okay, and the charge to mass ratio, as I said, is 1.75 into 10 to the power 11 coulomb per kilogram. This was discovered by J.J. Thomson, and that is why the credit of discovering the particle electron is given to J.J. Thomson, and in future he also received Nobel Prize for discovering electrons. Okay, and how is the electron represented? Electron is represented by E with a negative sign on top of it, or by this way. Now this is the representation of the particle. See, the charge is denoted on the bottom and the mass is denoted at the top. So charge is -1, so it is -1. Now this the mass is so small that it is neglected. So the mass of electron, that is why it is written 0. It doesn't mean that the mass of electron is actually 0. Electron has some mass, that is 9.1 into 10 to the power negative 31 kilogram, but the mass is so small that it is neglected. Okay, then this is all I've got for the discovery of electrons. So now let's talk about the discovery of protons by the scientist Eugen Goldstein. He discovered it from anode rays. Like electrons were discovered from cathode rays, protons were discovered from anode rays. Okay, so nearly all the conditions here which were there in the previous experiment are the same. Just a few differences is that in case of anode, the cathode is perforated this time, and there is zinc sulfide fluorescent screen behind the cathode. And one more difference is that the pressure is not that low. It is this time 0.1 millimeter of mercury, means 10 to the power -1 millimeter of mercury. So it is not that low when we compare it to the cathode ray tube experiment. Rest all the things, means all the arrangement is same. Not everything is same, the arrangement is same discharge tube, same vacuum pump, same cathode, same anode, same high potential and all. Okay, so now what are the properties of anode rays? Okay, so what are the properties of anode rays? So they are positively charged particles. So let's understand this. On doing all this setup, it was seen that some rays are traveling towards the negative plate. I'm not saying from the positive to the negative, I'm just saying some rays were seen to be traveling from the negative plate. And this diagram also I've made it in this way. See, if you see this diagram, I just made it that, see, these rays are coming from the cathode. Okay, but here the rays are not coming from the anode exactly. Anode does not produce anode rays. Anode does not produce anode rays. And one more thing, these anode rays are also known as canal rays. Okay, remember this, they are also known as canal rays. Okay, so yeah, so anode rays, they are not coming from the anode, they are just traveling towards the negative plate. And how we know this? First is that due to this perforations, and we have the zinc sulfide fluorescent screen which is producing fluorescence. So in the same way how we detected cathode rays, we detect anode rays as well. Now there is one difference between cathode rays and anode rays. It is that the anode rays are colored. Cathode rays were colorless, if you remember it. Anode rays are colored. Okay. Next up we have the properties of anode rays. So second property is that they also travel in the straight line and are produced from gaseous ions. Yep, this is the biggest difference between a cathode ray and the anode ray, because cathode rays were produced from the the cathode, but anode rays are not produced from anode. See how are anode rays produced? I'm just explaining you. I'm just trying to explain to you. Okay. See, let's suppose you have the cathode over here. Okay, and you have the anode over here. You have positive terminal, you have negative terminal. Okay, so I told you that the pressure is not that low, means some gas molecules are present over here. Okay, some gas molecules are present here. Now on applying this high voltage, the electrons from this gas molecules will come out. Okay, electrons will come out, and these electrons will start moving towards the negative plate. Now after these electrons come out, so what will be this electron? Means, let's suppose this is the gas atom and electrons have come out from it, so there will be a positive charge on this. All right, yeah, there will be a positive charge, so they will be now becoming ions. They are no longer molecules or atoms, they are now ions, and since they are positively charged, they start moving towards the negative terminal, that is the cathode. That is the reason why I said that anode rays are not produced from anode, they are produced from gaseous ions. I hope you understand this point, that they are not produced from the anode, they are produced from the gaseous ions. Okay. So here we were. So they are produced from gaseous ions. Same properties like cathode rays here, that they produce kinetic energy, they produce fluorescence, and yeah, they are also deflected in the electric field and magnetic field, as the positive particles should be deflected. Means electric field, they are deflected towards the negative plate. Means if we keep a positive plate and a negative plate over here, these rays will deflect towards the negative plate, so they are positive in nature. And oh my goodness, I'm really sorry. Okay, I just forgot to mention this point in the cathode rays. I mean, yeah, these cathode rays produce X-rays. I mean, when you have a metal target, when these cathode rays, fast moving cathode rays, strike any metal target of a very heavy atomic mass, then X-rays are produced. You don't have to think much about it, just learn this point, that when they strike any metal target of heavy atomic mass, then X-rays are produced. Okay, and there is this difference between cathode rays and anode rays, that is, these anode rays do not produce X-rays. They do not produce X-rays. Now this is the main point. These are all just properties, you just need to learn these or whatever, but this is the main point of it, of the entire experiment. The most striking difference between this cathode ray experiment and this anode ray experiment, so that was that on changing the nature of the gas, the property of anode rays change. Cathode rays, if you remember, I told you that the properties of cathode rays do not change, but the properties of anode rays change. And this is why, this is how it was proved that anode rays are not the fundamental particles of matter. Okay, anode rays are not made up of protons, but they are gaseous ions, so they are not fundamental particles. Let's suppose you have here, if you have here oxygen. Okay, so oxygen will have this nucleus and will have 8 electrons. Okay, 8 electrons. Let's suppose 1 electron comes out, so what will be left? A nucleus of oxygen and 7 electrons are still revolving, so it is not a proton, it is a gas ion. Okay, so yeah, these are not made of protons, they are made of gaseous ions, but they can be made of protons. How and when? Anode rays are made up of protons when the gas taken is hydrogen. Now what is that? I can tell you that you're confused. I hope not, but still, let's understand this. Okay, so the what is hydrogen atom? So hydrogen atoms contain only one proton and you have one electron. Okay, so on applying this high potential, this electron comes out, so you get only one proton in this. So this one proton, now if I'm asking that at this point in time we know they are protons, so we can tell that, but at that time, how in that time it was noted that this is the fundamental particle and all those things. Now you have to understand that we are studying about discovery of protons, but before the discovery of protons, J.J. Thomson in his atomic model had already stated that this atom is electrically neutral and electrons were discovered before protons. So they know that, means scientists at that time they know that hydrogen contains one electron. Now to be neutral, the atom must contain a positive charge, a unit positive charge. So if this electron is removed, so that unit positive charge, that single particle will only be present, and that single particle was later renamed to be proton by Ernest Rutherford. By whom? By Ernest Rutherford. So this is how protons are discovered. So that is what I wrote here. Anode rays are made up of protons when the gas taken is hydrogen. Otherwise, they are gaseous ions. I repeated this point 3 times in this same page. They are produced from gaseous ions. They are not made up of protons but gaseous ions. If the gas is hydrogen, then they are made up of protons. Otherwise, they are gaseous ions. I repeated this thing 3 times. So it is really important that anode rays are not protons. Anode rays are gaseous ions. Anode rays are protons only when the gas taken is hydrogen. Remember this point. Okay, so now as means protons are discovered. So what are the properties of protons? First is they are positively charged. Then their charge, means charge was calculated. So since they have to be, the atom has to be electrically neutral, and we know that the charge on an electron is negative 1.6 into 10 to the power minus 19 coulomb, then the charge on proton must also be positive 1.6 into 10 to the power minus 19 coulomb. Then only this charge is balanced. Yes or no? Yep, definitely. Then we have mass of proton. It was calculated to be 1.6724 into 10 to the power negative 27 kilogram. That is 1837 times the mass of an electron. Again, 1.6724 into 10 to the power minus 27 kilograms, or 1837 times the mass of an electron. In the same way, means as we discussed in electron, how is it this proton is represented? So proton is represented by P. So the charge is 1, so we have a 1, and it has a mass of unit mass. This mass of proton is taken to be unit mass, so therefore it has 1, P1. Now why have I written this H11? So what is the nucleus of hydrogen? So nucleus of hydrogen is just a proton because it does not contain any other particle than the neutron. So therefore we write here P for proton or H for proton, it does not matter. So that's all I got for the discovery and properties of proton. So let's now talk about the discovery of neutrons, the most mysterious particles, because the method of detection was very difficult because it is neutral. Okay, so now just a little bit of a story time. Yeah. If protons and electrons are discovered, why is this discovery done even? That was to check the mass. Means, for example, except hydrogen, if we take any gas like helium, so helium has 2 protons and 2 electrons. Now if we add the masses of these two, still the actual atomic mass of helium was not coming out. So that means there must be some other particle which is not a proton, not an electron, but it will have the same mass as that of a proton, and that particle was later discovered as neutron. Same mass. Why I'm saying this? Because helium 2 protons are there, so 2 AMU they calculated with the knowledge of protons and electrons, but the mass was coming out to be 4 AMU. Similarly, if I have 8 oxygen, so 8 protons, 8 AMU, but mass is coming out 16 AMU. So the scientists kind of figured it out that the mass should be almost equal to that of a proton, and they must be electrically neutral. So this was finally discovered by Sir James Chadwick in 1932 by bombarding alpha particles. Now what is alpha particle? Alpha particle is helium nucleus. I mean, if you take out, if you have this is a helium nucleus and you have two electrons revolving here. So if we take out these two electrons, you just have helium nucleus with two protons and two neutrons, and this is known as the alpha particle. So he bombarded this nucleus of beryllium using alpha particles. So what was the result of the reaction? That is, beryllium was bombarded with alpha particles to give carbon nucleus and one particle which had no charge but mass almost equal to that of proton. Again, which had no charge but mass almost equal to that of a proton, and this particle was named as neutron by Sir James Chadwick only because it was electrically neutral. So now let's talk about the properties. So electrically neutral, therefore charge on neutron is 0, and a neutron is represented in this form, n, 0 and 1. Now let's talk about mass of a neutron. So it is nearly equal to the mass of a proton but not exactly the same. Neutron is slightly heavier than the proton. I guess you can see it from here. It is 1.676 into 10 to the power negative 27, whereas the mass of a proton was 1.6724 into 10 to the power negative 27. So if we consider 3 decimal places, it is 1.672 and it is 1.676. So definitely neutron is heavier. So that's all I got for the discovery of neutrons, and thus this concludes this video. Thank you very much for watching. I hope you enjoyed it.